Hello, Legacy students. Marsh here. So today we're going to be looking at properties of roots and exponents. So we're looking at rational exponents. You're going to watch your foldable. It's a stacked foldable today. Some form of writing utensil, and then a calculator to do maybe some fraction work. Our essential question today, how do the properties of integer exponents extend to rational exponents? So let's first remember our properties of exponents. When I am multiplying a like base, you know what, I'm going to change it back to dark red. When I'm multiplying a like base, I'm going to add my exponents, right? So I'd get x to the 8th. When I would multiply, or when I was taking a power to a power, we multiplied our exponents, right? So this would be x to the 15th. When I had a product to a power, we kind of almost, not for lack of a better word, distributed that power to each piece in there, and then multiplied our exponents if we had any to multiply. So that would be a to the 5th, because 1 times 5, and then b to the 5th. If I had the same base on top of one another, dividing them, I subtracted my powers, right? So I'd get a to the 2nd. Here, if I had a quotient to a power, just like when we had a product to a power, we distributed. So I would have a cubed over b cubed. And then don't forget negative exponents, those moved us down. Or if it was on the bottom, moved us up on a fraction, right? Now, what if we need to simplify an exponent that is a fraction? So what we're going to be looking at in our foldable today is this first tab right here, Simplify Exponents. Let's try them. So I have 2 to the 3/2 times 2 to the 5/4. Notice I have the same base. They're both 2s, which in that case means I don't have to worry about the base. They're the same thing. I need to add those exponents. So I'm going to have a base of 2. Notice it doesn't change into a 4 because the base is staying the same. I'm going to show my work here. I'm going to do 3/2 plus 5/4. So I need to get a common base, right? Or common denominator, excuse me. So this would be 4, 6. So 6/4 plus 5/4 is 11/4. So my answer is 2 to the 11/4 power. Now, on a calculator, if you are like, ooh, Marsh, adding fractions has never been my strong suit, any calculator, scientific or graphing, should be able to do fractions. And if that is something you need to discuss with me, because you need to know how to use your calculator to accomplish that task, please let me know. I'll be very, very willing to show you how to do that. The next problem, I have -2 to the 2/7 times -2 to the 2/3. Notice, again, I have the same base. I have -2. So I'm just going to add my exponents. So I'm going to go -2 to the 2/7 plus 2/3. Common denominator, 21. So I'll have -2 to the 6/21 and 14/21, because I'm multiplying these guys by 3 and these guys by 7. Okay. I would get -2 to the 20/21. And then the last thing I do want to do is I do want to make sure this doesn't simplify, and in this case it doesn't. I now have a same base dividing them. So I have a quotient, right? And when we had a quotient, we just subtracted our exponents. So the 8s are still going to stay 8. You're not going to get 1 there because the exponents, technically this is not 8. This is 8 to the 9/7. Okay? A little bit more than 8 is actually what that is. So we're going to just do 8 to the 9/7 minus 1/2. I'm going to subtract those exponents there. I need a common denominator, it looks like. So I will get 18/14. Whoops. Pen's not writing very well. 7/14. So I gotta multiply this guy by 2, this guy by 7. So 18/14 minus 7/14, I will get 8 to the 11/14 for my final answer. I know, fraction city here today. This one, notice I have a subtraction, a negative exponent down here. So couple of options. I could do subtraction. Okay, I could subtract those exponents because they have the same base. However, I like to take negative exponents before I do subtraction, and everything else, I like to move them. So technically, this guy needs to move up here. So this is 4 to the 7 halves times 4 to the 3 halves. Because remember, when it moves to the top, that means you change the exponent's sign, right? Well, now I just need to get and add those exponents. So I'll have 7 halves plus 3 halves, which in our case is 4 to the 10 halves, which in our case is 4 to the 5th. And 4 to the 5th is the number, using my calculator here quick, 1024 for my final answer there. Oh, did I skip a page? No, I did not. Okay, now these ones, again, notice I have the same base, but you're like, well, Marsh, this 3 up here, this numerator of the 3 doesn't have a power. It does. It has a little 1 up there. So whenever you don't see that and you need to maybe fix it to make it so you can see it, so I'm going to put a little 1. So now I can subtract my exponents, right? So I'm going to do 3 to the 1st minus 1/4. 1 is the same as 4/4, so I'm just going to change that around here. So 4/4 minus 1/4 would be 3 to the 3/4 power. And since that does not simplify, I'm not going to do anything further. Remember, when we had a power to a power, we multiplied, right? So I'm going to do 4 to the 2/6 times 3/4. That means we're just going to multiply across, though, not cross multiply. So we're going to multiply and get 2 times 3, which is going to give us 6. 6 times 4, which is going to give us 24. 6 over 24 simplifies. That is 4 to the 1/4 power. Let's try another. So I have a product, aka multiplication, to a power. So I got to do, just like last time when we would have like this, I need to distribute that power, and then we multiplied those numbers, right? So I'm going to distribute the 2 in, and I'm going to multiply. So I'm going to get x to the 1/2 times 2, and y to the negative 3/4 times 2, which would simplify to x to the 1st, right? Because 1/2 times 2 is 1. And then y to the, I'm going to make that negative 2 over 1, or just a positive 2 over 1. So I'd get negative 6/4, which is technically negative 3/2, right? And since it's negative, it needs to move to the bottom of a fraction. So I'm going to get x over y to the 3/2 for my final answer there. A lot of weird answers, right? But same exponent rules you were using before. It just is not as comfortable as it is with those integer numbers. Let's try another one here. So I have 2 things multiplied. I'm just going to multiply my like bases, which means I'm going to add my exponents. So I'm going to go x to the 2/3 plus 3, and I'm going to put him over 1. And then I'm going to do the same thing to the y's. Y to the negative 2 over 1 plus negative 3 over 4, just like that. I need to get a common base, or a common denominator, excuse me. I'm going to multiply by 3 here. I'm going to get x to the 2/3 plus 9 over 3. I'm going to do the same thing to the y's. I'm going to get y to the negative 8/4 plus negative 3/4. So that will give me x to the 11/3, y to the negative 11/4. Since it's a negative exponent, it needs to move down to the bottom. Make sure you take the entirety, make sure the base comes with. So I'll get x to the 11/3 over y to the 11/4 for my final answer. Go ahead and try this one. So pause the video for me and see if you can get the right answer. Did you pause it? I don't think you paused it. You should double check that. Okay, I've waited. You should have paused. So I'm going to distribute that 5, right? That's the first thing we're going to do here to clean this up. So I'm going to have x to the 2/3, who's hanging out front. I'd have 81 to the 5/4 power, x to the 10/3, and y to the 5th. I'm going to combine those x's together. So I'm going to get 81 to the 5/4, x to the 12/3, right? We're going to add those exponents together. Y to the 5th. 12/3 is just 4, so this is 81 to the 5/4, x to the 4th, y to the 5th. Now, you may have stopped here. Careful. 81 to the 5/4. He simplifies. If you find your gold card here, you will find that this will simplify. I'm going to go off to the side here. Little sidebar. 81 to the 5/4. Last time we learned something, we talked about how a rational exponent can turn into a radical notation, right? So I'm going to change this one. This would be the 4th root of 81 to the 5th. The 4th root of 81 is 3, right? So technically, that's 3 to the 5th. And 3 to the 5th is, looking at my card here, 243. So this 81 to the 5/4 simplifies to 243. So we're going to want to write our new answer. So whenever you have a simple number to an exponent, please double check if you change it to your other form, does it simplify? And the one that I would be looking for the most is the denominator. Is the base a perfect root of that denominator? For example, 81 is a perfect 4th. That's how I kind of knew that I had to worry about that one. So the official answer would be 243, x to the 4th, y to the 5th. Try one more for our video. So I'm just going to combine some like terms here. Oop, lost my pen. So I just got 16 to the 5/4, x to the negative 10/3, because I just got to add those exponents, right? This is y to the 1st, so that would be y to the 4th. Negative 10/3 does not simplify, but I do need to take care of that negative, so I'm going to take care of that first. Just like that. And then I'm going to do a little sidebar conversation. 16 to the 5/4. I'm very sus about that 16 to the 5/4, so I'm going to convert it to its other form. 4th root of 16 is 2. And I know 2 to the 5th is 32. So I can rewrite this as 32 y to the 4th over x to the 10/3 for our final problem of our video. And that is the end of this video. Again, If you are not strong when it comes to fractions and adding them and multiplying them and all of that in between, please let me know so I can show you how to use your calculator so you do not feel as scared of your fractions, because that is not something that we want to hinder our algebra. We want to be able to use our calculator to help us. But with that, that is the end of the video. I will see you later, Sabers.